Today we're going to learn about the other trig functions. So in the previous lesson we learned about sine and cosine. And today we're going to learn about tangent, cotangent, secant, and cosecant. And all four of these trig functions will directly evolve from sine and cosine. So with a very strong understanding of the sine and cosine functions, these four will just be using those to find its values. So our definition. So as a reminder, the sine function was defined as y over r on a coordinate system, and then just the y coordinate if on the unit circle, because r would then be 1. And in SOHCAHTOA, I believe you've learned that sine, so, would be opposite over hypotenuse. Cosine is defined as the x over the r and the x coordinate if on the unit circle. And in the SOHCAHTOA, it is adjacent over hypotenuse. Now, tangent, one of our new functions, is defined as y over x, or the opposite over the adjacent in a right triangle. Tangent is also defined as the sine over the cosine, because as you remember, the sine is the y coordinate and the cosine is the x coordinate. Sorry about that. The x coordinate. Tangent is y over x. So if you remember, sine is y over r, cosine is x over r, and tangent is y over x. If on the unit circle when r is 1, sine is just the y, cosine is the x, tangent would be y over x also. Now, the other three functions are just the reciprocal trig functions. These are not going to be used very often, but it's good to have a small knowledge of them. They're called the reciprocal trig functions. Cotangent, just by its name, is obviously the reciprocal of tangent. Remember, the reciprocal is just flipping the fraction. So since tangent is y over x, cotangent would then be x over y, or cosine over sine, or adjacent over opposite in a right triangle. Cotangent's reciprocal of tangent. Secant, then, is the reciprocal of cosine. Now, how I remember this is by reciprocal means to flip. So we've got secant, cosecant, cosine, and sine. Some start with a C, some start with an S. Because we flip them, the one that starts with an S will have a reciprocal that starts with a C, and vice versa. The one that starts with a C, its reciprocal would start with an S. So that means reciprocal of secant is cosine. Since cosine was x over r, secant will be r over x, or 1 over x on the unit circle. Cosecant starts with a C, so it's the reciprocal of sine, which starts with an S, which means cosecant will be r over y, or 1 over y on the unit circle. So we've got cotangent and tangent are reciprocals, secant and cosine are reciprocals, and cosecant and sine are reciprocals. So now we're going to evaluate them exactly how we did in the previous assignment. So if theta is a second quadrant angle and tangent of theta is negative 3 over 4. So I would just draw an angle in the third quadrant. Okay, now some of you struggle with this a little bit in the assignment. I talked about forming the triangle with the x-axis. So from this point right here, I need to go to the x-axis, which would be down. That forms my right triangle. This is the x, this is the y, and this is the r. Now, according to this, given us tangent to be negative 3 over 4, remember tangent is y over x. So the y would be negative 3, or actually it would be positive 3, and the cosine, the x, would be the negative 4. So y would be positive 3, x would be negative 4. Using Pythagorean theorem, we've got a 3, 4, r must be 5 in this case. So then therefore, and I would continue to do these all in the same order. I'm going to start with cosine. So cosine of theta is x over r, which should be negative 4 over 5. Sine of theta is y over r, which should be 3 over 5. Tangent of theta, they gave it to us, is a negative 3/4. That's also y over x. And then I would do these in this order: secant, cosecant, cotangent. I put them in that order because that's the reciprocal of cosine, reciprocal of sine, reciprocal of tangent. So then what I do is I just flip them. So since cosine was negative 4/5, secant would be negative 5/4. Cosecant is reciprocal of 3/5, which would be 5/3. Cotangent is reciprocal of negative 3/4, which would be a negative 4/3. The next example, same type of problem, says if theta is a fourth quadrant angle. So I just draw some angle in the fourth quadrant, and then from here I go to the x-axis. So here I go up, or vertical. Cosine, remember, is x over r. So my x is 24, and my r is 25. Then I would use Pythagorean theorem to find this y coordinate. So I do 25 squared minus 24 squared. Take the square root of that, and I believe I get 7. That's another Pythagorean triple. And that would be negative because I'm going down. So then again, I'm going to do these in this order again, staying consistent. Cosine is 24 over 25. Sine is in y over r, which would be negative 7 over 25, sorry. Tangent is y over x, which would be negative 7 over 24. And then secant, it's the reciprocal of cosine, so that'd be 25 over 24. Sine's reciprocal is cosecant, which would be negative 25/7. Reciprocal of tangent is cotangent, which would be a negative 24/7. So as you do these, remember that you'll see that always 2 of them are positive and the rest are negative. One thing to help you with this is a little acronym called a SMART trig class. This tells you which ones are positive in what quadrant. A stands for all, S means sine and its reciprocal, T means tangent and its reciprocal, and C means cosine and its reciprocal. So since this was a fourth quadrant angle, the 2 that must be positive must be cosine and its reciprocal, secant. You can see those 2 are positive and the other 4 are negative. Finding exact values of quadrantal angles. A quadrantal angle is one formed by the axis. So 90 degrees is straight up. That's going to intersect the unit circle at the point 0, 1. So then my values would be cosine of 90 is the x coordinate, which is 0. Sine of 90 would be the y coordinate, which is 1. Tangent of 90 would be y over x, 1 over 0. Dividing by 0 is undefined. And then I'm going to do reciprocal. Secant of 90. The reciprocal of 0, putting 0 down the bottom of the fraction, the reciprocal of 0 will always be undefined. Cosecant of 90 is the reciprocal of sine. The reciprocal of 1 is 1. And then cotangent of 90 is the reciprocal of undefined. Flipping undefined would be 0. 3 pi over 2, this is an angle in radians. It's equal to 270 degrees. So we're talking about right here, which has the coordinates 0, negative 1. So then the cosine of 3 pi over 2 is the x-coordinate, which is 0. The sine of 3 pi over 2 is the y-coordinate, which is negative 1. Tangent of 3 pi over 2 would be y over x, dividing by 0, undefined. And then I've got my reciprocals. Secant of 3 pi over 2 is the reciprocal of 0, which is undefined. Cosecant of 3 pi over 2 is the reciprocal of negative 1, which is negative 1. And the cotangent of 3 pi over 2 is the reciprocal of undefined, which is 0. Find the exact values of a special angle. So for example, 120 degrees. So I'm going to draw this angle. 120 is going to be about here. Drop down to the x-axis. Here's another thing that you struggle with a little bit. If this is 120 degrees, this has to be the 60-degree angle. That has to be the 30. So this is 1/2. This is root 3 over 2. And that one is negative, and the root 3 over 2 is positive. So now, finding these, cosine, I'm not going to write 120 each time, but the cosine value of this would be the x-coordinate, which is negative 1/2. The sine would be the y-coordinate, which is root 3 over 2. The tangent would be the y over the x. That would be root 3 over 2 over negative 1/2. Those 2's would just cancel. I have root 3 over negative 1, which is a negative root 3. That's the exact value of the tangent of 120. And then I do the reciprocals of each one. Secant's reciprocal cosine, flipping that would be negative 2. Cosecant is reciprocal of sine, flipping that would be 2 over root 3. I need to rationalize that. Can't have a square root in the bottom. That'd give me 2 root 3 over 3. Cotangent's reciprocal of tangent, which would be 1 over negative root 3. Rationalize that one. And I get negative root 3 over 3. 3 pi over 4, this is an angle in radians. That's about 135 degrees, or exactly that. That angle would be about right there. Drop down to the x-axis, it's going to be a 45, 45, 90. Both my x and my y will be root 2 over 2. The x will be negative again. So therefore cosine would be negative root 2 over 2. Sine would be positive root 2 over 2. Tangent y over x would be negative 1. And then my reciprocal secant would be negative 2 over root 2. If I rationalize that, I get negative 2 root 2 over 2. The 2's cancel. It would just be negative root 2 for secant. Cosecant, I'd get the exact same thing, but positive, so it would be a positive root 2. And then cotangent is the reciprocal of negative 1, which is also negative 1. So we're doing the same types of things, just extending it to the 4 new trig functions. On today's assignment, I'll ask you to do a little video of you demonstrating and explaining the problem in words. Have a great day.